Welcome to the Maths 2 component of the online BSc degree in data science. In today's video, we are going to look at systems of linear equations. Okay, so what are the contents of this video? So let's see what they are. What is a system of linear equations? What is its relation with matrices? And finally, how many solutions can it have? Okay, so these are the three things we are going to see today. Let's begin with an example. So in this example, we have three buyers and we have three items. So buyer A buys rice, 8 kgs of rice, 8 kgs of dal and 4 liters of oil. Buyer B buys 12 kgs of rice, 5 kgs of dal and 7 liters of oil. And buyer C buys 3 kgs of rice, 2 kgs of dal and 5 liters of oil. Okay. So suppose these buyers paid some amount of money to the shopkeeper, namely A paid rupees 1960, B paid rupees 2215 and C paid rupees 1135. Okay, so I have this data. Okay, now we want to find the price of each item using this data. Okay, so how do I write this as a system of linear equations? So we'll assume that the price of rice is rupees X per kg. We'll assume that the price of dal is rupees Y per kg, and we'll assume that the price of oil is rupees Z per liter. So then what do we get for the first buyer? We get that 8 times X, because he or she bought 8 kg of rice. So 8 times X plus 8 times Y, 8 kgs of dal, plus 4 times Z is 1960. Okay, similarly we get the next two equations. Okay, so this is what a system of linear equations looks like. And now from this data we would like to solve this system and get what is the price of rice, dal and oil. Okay, so I'm going to quickly solve this. So I think many of you may have solved such things in school. So how do we solve this? So maybe we can take the first equation and divide it by 2. So if you do that, we get 4x plus 4y plus 2z is 980. Okay, this is the first equation divided by 2. And then we will multiply this new equation by 3 so that I get a 12x. So 12x plus 12y plus 6z, which is 2940. Okay, then I'll take this equation and subtract out the second equation over here. Okay, I will subtract out the second equation over here. Okay, so if I do that, what do I get? So the 12x is subtracted out and what we get is 7y minus z is 725. Okay, so now we have an equation in terms of y and z. Now similarly for the third equation, what we can do is we can use the third equation and multiply the third equation by 4 so that we get a 12x. So multiplying the third equation by 4, we will get 12x plus 8y plus 20z is 4 times 1135, and then we'll use this this equation and subtract out the second equation. So what we get is another equation in terms of y and z. So the equation we get in terms of y and z is 3y plus 13z is 2325. Okay, so I'll encourage you to do this. Okay, so now we have two equations and two unknowns, namely in y and z. So let's try and solve this. So well, we can actually solve this by putting z equals 7y minus 725 and substitute in the second one. So if you substitute in the second one, we get 3y plus 13 times 7y minus 725 is 2325. Okay, so if you simplify this, what you will get is 94 times y is 11,750. So then y is 11,750 divided by 94, which is 125. Okay, so we have computed the price of dal. It is rupees 125 per kg. So we'll substitute y is 125 in this equation over here, and we'll get z. So z is from here we'll get that z is 150. Okay, and then now we know y and z, so we'll put them in some suitable equation, and we can get x. So x is going to be 45. Okay, so I'll encourage you to check this. Okay, so what was the point of this? The point of this was we had a real life problem involving some costs and so on. So we had three equations, and then we used some unknowns to denote the things that we wanted to compute, and then we had three linear equations in those three unknowns, and then we solved this system of linear equations. Okay, and we computed that x is 45, y is 125, and z is 150, which means the price of rice is rupees 45 per kg, the price of dal is rupees 125 per kg, and the price of oil is rupees 150 per liter. Okay, so this, I hope this convinces you that solving a system of linear equations is something useful. Okay. So what is a system of linear equations? So before that we have to ask what is a linear equation? So a linear equation is something of the form a1x1 plus a2x2 plus an(xn) is b. Okay, this is what a linear equation looks like. This is one linear equation. Okay, so what are the x1, x2, xn? These are variables or unknowns. Yeah, these are the things that we want to compute. This was like the x, y, z in our previous example. Okay, and then what are the a1, a2, ans? These are what are called coefficients. Yeah, these are going to be real numbers. These are things we'll assume. These are numbers we'll assume that we know. Okay, and then b is also a real number. So here's an example. So 2x plus 3y plus 5z is minus 9, and here x, y, z are variables, and the 2, 3, 5 are coefficients. Okay, so what is a system of linear equations? So a system of linear equations, so that means we have several linear equations. Okay, we saw what is one linear equation. So it's something of the form a1x1 plus a2x2 plus an(xn) is b. Instead, now we have many such equations, but in the same set of unknowns. Okay, so x1, x2, xn remains the same, but the coefficients and the constant at the end change. Okay, so here's an example. So you have 3x plus 2y plus z is 6, x minus half y plus 2/3 z is 7/6, and 4x plus 6y minus 10z is 0. Okay, so I'll encourage you to solve this equation similar to how we did it in the first example. So if you do that, you should get the answer x is 1, y is 1, and z is 1. Okay, so what are the unknowns or the variables here? The x, y, and z are the unknowns or the variables. So traditionally you represent, if you have one unknown, it's x. If you have two unknowns, it's x and y. If you have three unknowns, it's x, y, and z. And if you have four or more unknowns, you take x1, x2, x3, x4, and up till as many unknowns as you have. Okay, so what is the solution to this system of linear equations? That means if you put x equals 1, y equals 1, and z equals 1 in this system here, right, then these equations are solved. So let's check that. So 3 times 1 plus 2 times 1 plus 1 is indeed 6. Okay, 1 minus half times 1 plus 2/3 times 1. So that's 1 minus, so that's half plus 2/3, which is indeed 7/6. And then similarly you have 4 times 1 plus 6 times 1 minus 10 times 1 is 0. Okay, So I hope it mean you understand what it means for a system of linear equations to have a set of solutions. So when you put x, y, and z to be some particular numbers, then these equations should be satisfied. Okay, that means these equalities should be true. Okay, that's when we say we have a solution. Okay, so what is the general system of linear equations? So you have m linear equations. That means you have m equations and you have n unknowns. So n unknowns means you have x1, x2, xn. Okay, then how do we write these? We write these as a11 x1 plus a12 x2 plus a1n xn is b1, a21 x1 plus a22 x2 plus a2n x2 is b2, and all the way up to am1 x1 plus am2 x2 plus amn xn is bm. Okay, so if you want the ith equation, then this is ai1 x1 plus ai2 x2 plus ain xn is bn. Okay, this is the ith equation in this system. Okay, fine. So what is the connection with matrices? Okay, so this is the really important part of this video. So the system of linear equations is equivalent to a matrix equation of the form a times x is b. So in the previous video we have seen what it means to multiply matrices. Okay, so here a, x and b are matrices. So a is an m by n matrix, and what are the entries of this matrix? They are exactly the aij's that we saw in our previous slide. Yeah, so this matrix A consists of the aij's. X is a column vector with n entries. What are the entries? x1, x2, xn, exactly our unknowns. And B is the column vector b1, b2, bm. Okay, so this is A. That's from our previous slide. These are the coefficients. So this A is called the coefficient matrix. What is X? X is a column matrix, so that means it consists of one column. So it's the column x1, x2, xn. Yeah, it's a matrix with n rows and one column. Yeah, it's a column matrix consisting of the unknowns. And B is the set of constants. So it's again a column matrix consisting of the constants. So this is a m by 1 matrix. Yeah, this is n by 1 and this is m by n. Okay, and now if you multiply these, first of all let's ask, does it make sense? Indeed, this is m by n and this is n by 1. So it makes sense to multiply these, and whatever the product is, it will be of size m by 1. Okay, so we are saying that a product is exactly the left hand side of the system of linear equations that we had on the previous slide. Okay, and on the right hand side we'll have these constants b1, b2, bm. Okay, so the previous system can be expressed in the form ax equals b. Okay, so the important part here is that any system of linear equations can be expressed in terms of matrices as a matrix by matrix multiplication. Let's look at some examples. So let's look at this example that we had before. 3x plus 2y plus z is 6, x minus half y plus 2/3 z is 7, 6, 4x plus 6y minus 10z is 0. So how do we represent this in terms of matrices? So in terms of matrices, this is the coefficient matrix. So we collect together all the coefficients and put them in the correct places. So the first row is 3, 2, 1. That's what occurs as the coefficient in the first equation. The second row is 1 minus half 2/3. That's what occurs in the second equation. And the third row is 4, 6 minus 10. That's what occurs in the third equation. Okay, what is x? X is x, y, z. The unknowns or the variables. And what is b? B is the set of constants on the right. So 6, 7, 6 and 0. And I'll encourage you to multiply a and x. So multiply a by x and see that you get exactly this thing over here as a as a column matrix. So you get exactly this as your matrix. Okay, this is A times X, and this thing on the right is B. Okay, and what are this system of linear equations saying? Saying Ax is equals B. Okay, so we have rewritten this example as a in terms of matrix multiplication. Okay, let's look at our first example. So this was 8x plus 8y plus 4z is 1960, 12x plus 5y plus 7z is 2215, 3x plus 2y plus 5z is 1135. Okay, how do we write this in terms of matrices? So the coefficient matrix here is going to be 8, 8, 4, 12, 5, 7 and 3, 2, 5. The matrix X, which is a column matrix, that will be X, Y, Z, and the matrix of coefficients, sorry, of constants is going to be 1960, 2215, 1135. Okay, and once again I'll encourage you to check that Ax is equals B exactly captures the system of linear equations upstairs. Okay, now I'll point out one small strangeness in this entire notation. You will see that the matrix here is called X, whereas we also have a variable called X. Okay, so be very careful to distinguish between these two. Okay, so which one is your variable and which one is your matrix. So when we are writing this matrix, this has 3 rows and 1 column. So this is a matrix, this is a column matrix of size 3. So 3 rows and 1 column. And inside it is the 1th entry is X, which is exactly our variable inside in our equations. Okay, so this is an unfortunate fact that there is a clash of notations, but that's how it is, and it with some practice you will get used to it. Okay, so we have seen 2 examples of how the connection between systems of linear equations and how to represent them in matrix terms. So now let's talk about solutions. Okay, so solutions to a linear system. So we saw I explicitly found out the solutions for the first example, and I asked you to check that X is 1, Y is 1, Z is 1 is the solution for the second example. So in general, what can we say about solutions of a linear system? Okay, so it turns out that there are only 3 possibilities. Okay, either a system has infinitely many solutions, or a system has a single unique solution, or a system has no solution. Okay, so these are the only 3 possibilities. Okay, so it cannot happen that a system of linear equations over the real numbers has only 3 solutions. Okay, this is not possible. Okay, if it has 3 solutions, it will have infinitely many solutions. Okay, it can't have exactly 3 solutions. So it can have either 0 solutions, 1 solution, or infinitely many solutions. Okay, okay, so let's see examples of where this comes from. So suppose we have 2 buyers, A and B, and buyer A buys 2 kgs of rice and 1 kg of dal. Buyer B buys 4 kgs of rice and 2 kgs of dal. Okay, and they pay 215 rupees and 430 rupees respectively. So again, as in the first example, we want to find out the price of rice and the price of dal. So we'll put this into the form of linear equations. So if you follow the first example, you will quickly see that this is 2 times x plus y is 215, 4 times x plus 2y is 430. Okay, and there are infinitely many x and y satisfying both the equations. Okay, so I'll encourage you to find out why that's the case. Let me give you one example uh, I mean, let me at least show you two solutions, and you can find as many more as you want. One solution is you take x is 0 and y is 215. Okay, that's one solution. Okay, so check that indeed this works. Another solution is x is 215 by 2, so that's 107.5, and y is 0. Okay, so this is another solution. Okay, and I'll encourage you to find more solutions. Okay, so what is happening here in terms of so there is some geometry involved, so let's draw this picture. So the idea is that if you draw, remember that if you have uh, um, the equations correspond to straight lines. Yes, this is something you have seen in maths 1. So you have 2x plus y is 215 and 4x plus 2y is 430, and both of them give you the same straight line. Okay, so any point on this line is going to satisfy, is going to be a solution. So every point on this line is a solution. Every point on the line is a solution. So now you can find as many solutions as you want. Okay, so this is the geometry behind why it has infinitely many solutions. Let's do an example where it has no solutions. Okay, so again we have the same situation, namely A and B go to the shop, buy the same amount of rice and dal as they previously did. So 4 kgs of rice and 2 kgs of dal, and 2 kgs of rice and 1 kg of dal respectively. But this time the seller gives a discount to B. Okay, the seller is in a happy mood, the shopkeeper, and they give a discount to B. Okay, so A paid 215 rupees and B paid 400 rupees. Yeah, in the previous example B had paid 430 rupees. Yeah, this time they got a discount of 400 rupees. Okay, now after returning home they tried to solve this system. Again we put x and y to be the price of rice and dal respectively. So we get 2x plus y is 215, 4x plus 2y is 400. Let's try and solve this system of linear equations. So if you try and solve this, so let's take the first equation and double it. So if you double the first equation, you get 4x plus 2y is 430. On the other hand, the second equation says 4x plus 2y is 400. Okay, so what does that mean? That means 400 is equal to 430. Okay, so there's something really wrong. Okay, this is something is going very wrong. So okay, so of course we know that 400 is not 430. That means there is no x and y for which this can be solved. Okay, so there's no solution here. What goes wrong? So the reason there's no solution here is that if you draw the lines in this case, they are parallel lines, so they won't intersect at all, and the intersection is exactly what will give you the solution. So in the previous case you had both the equations at the same line, so it was like you had two lines which were the same, so they intersected in infinitely many points. So here you have two lines which are parallel, they don't intersect at all, and so there's no solution. Okay, so finally let's do the example, the last example where you have a unique solution. So in this case, buyer A buys 2 kgs of rice and 1 kg of dal, and buyer B buys 3 kgs of rice and 1 kg of dal, and buyer A pays 215 rupees, buyer B pays 260 rupees. Let's write down the equation. So it's 2x plus y is 215, 3x plus y is 260. Okay, and I'll encourage you to solve that equation. The point here is you have two lines. 2x plus y is okay, maybe let's go back. 2x plus y is 215 and 3x plus y is 260. So it's clear from here that x is 45, and once we know that x is 45, we can compute that y is so 215 minus 90 So that's 125. Okay, so this is like in our first example. So the price of rice is 45 rupees per kg and the price of dal is 215 rupees per kg. And you can check here that that's exactly where these intersect. So this is on the x-axis, it intersects at 45, and on the y-axis you have 125, and that's exactly the point of intersection. Okay, so that's why there's a unique solution. So you can draw these lines, and wherever they intersect is where you have an equation, you have a solution. Okay, so let's recall quickly what we studied today. We have studied what is a system of linear equations. We have studied how to write it in terms of matrices, uh, particularly using matrix multiplication with unknowns, where x was a column matrix of variables. Okay, and then we have seen that what is a solution to a system of linear equations, and then we saw that there are three possible cases. Either a system has no solution, or it has one unique solution, or it has infinitely many solutions. That's all for today. Thank you.